Hi everyone. Today what we're going to work our way through is graphing trig functions. And to do that, we're going to examine transformations to those trig functions. So what you'll see on the screen, and I'm just going to highlight a certain area right now, is that what we have is this section of our base sine curve. And what we're going to do is we're going to then deal with transforming that curve into about as ugly of a graph as what we could get. And what I mean when I say that as ugly of a graph is it's a graph with the most transformations we could see. So if you take a look on that page on your screen, you're going to see all those components. And so I've just plugged in an A, a K, a C, and a D as placeholders for those transformations. We should be good that if we saw an A value, for instance, that we could have a vertical stretch then by a factor of A. And if that A happened to be a negative, well, then there would also be a reflection in our x-axis. Read down all of those blue transformations, and we should see that they line up with everything in our background. Now, one issue that I just want to make sure that we are good with is notice I didn't make any sort of statement about what happens if K was negative. We should all be good that given the position of K in our equation, that if K was negative, then we would have a reflection in the y-axis. However, we should be able to recognize that we don't really have to address reflections in the y-axis because of the nature of a trigonometric function. Because these trig functions are all periodic, because they repeat over and over and over, that we never have to worry about reflecting our curve in the y-axis because we can always get to our graph in a different way. And so we never really address reflections in the y-axis. It's nothing that you would need to focus on. Everything that we see in blue and green we should be good with. But where I want you to focus in on now is what you see in red. That in last lesson, as we worked our way through some stretches, we were able to nail down the idea that our A value represents the amplitude of our function. We have our best friend in our relationship that period is equal to 360 over K. You'll then notice that with trig curves, we actually have some different terminology, that we don't refer to it as a horizontal shift, even though we interpret it that way, but instead we refer to it as a phase shift, that we're going to take the cycles and we're going to move their positioning horizontally. So we have that phase where something occurs is going to shift. So it's a phase shift. Lastly, you'll notice that we have our vertical shift. And an important feature for us is that when y equals d, that is our vertical shift, that becomes the equation of our axis, the middle of our trig curve. So what you want to do is we should already have the blue and the green in our back pocket. What we're going to do today is we're going to focus in on the red and make sure that we can apply all these transformations to trig graphs and have an understanding of some key properties. So let's jump in. As you see on the screen, what we're going to do is we're going to graph the function y equals negative cos 2 times x minus 60 degrees minus 1, a pretty ugly function, in the domain greater than 0, less than 360. So when we scan the grid that's provided, you'll notice that for us to graph that function, we have to fill in the whole grid. Okay, what I'm going to ask you to do, even though it's not required in the problem, is I'd like you to put a quick graph down of what your base cos curve looks like. And so given everything we've done, that should take you 10 to 15 seconds. So pause the video right now and put in your cos graph. Okay, we should be back. We should know that our coast curve starts at the top and then falls and hits my 0 at 90, my minimum at 180, my 0 at 270, and my max again at 360. And so, if we put on a quick sketch, there is my base graph of cos x. Now, what I'm going to do is I'm going to walk through this one, and I'm going to deal with it using intermediate graphs. Again, this would never need to be shown, and in fact, I would like to motivate you to not show them. But since this is the first time we've graphed a trig function that's been transformed, I think it might help us to see it. So what I'm going to do is I'm going to deal with the transformations in its part. The first one that you'll see me kind of highlight in red, I'm going to deal with that negative. And we know that that negative would be a reflection in the x-axis. So this maximum that occurs at 1 would get reflected across the x-axis to a minimum at -1. Any points on the x-axis would stay the same. This minimum gets reflected across the x-axis. My 0 stays the same. My max becomes a minimum. And I can connect all of my points with a smooth curve. That red function that I just created was y equals negative cos x. Okay, so I've dealt with the reflection. Now I'm going to work my way through and deal with that stretch, the effect of the 2. Well, I know that if I'm multiplying by 2 on the inside, then that's a horizontal stretch by a factor of 1/2. So every point on my red graph has to become half the distance to my y-axis. So if I'm on my y-axis, it doesn't move. This 0 that occurred at 90 then has to be half the distance, so 45. This maximum that occurred at 180 has to be half the distance, 90. And if I proceed working my way through, this 0 at 270, well, half of 270 is 135. And since my scale on my x-axis is 30 degrees, then I would go 30, 60, 90, 120. Now I would have to go another half to get in between. That would put me at this location. Now, for some of us as we work our way through, we may have found that that may have been difficult to kind of get to that point. And so, as we were working our way through, instead we may have used grid lines for confirmation and said that 270 occurs on 9 grid lines. So half of that would have to be 4.5 grid lines. And so if I go 1, 2, 3, 4.5, I get a little confirmation. The 360 going to a half gets me to 180. And what I then have is I have this as my new trig curve. Now, I would argue to you that if you want to use intermediate graphs, don't complete them for the given domain. You know that what you see in blue right now is one cycle of your curve. And so if that was the final graph, you'd have to repeat it for the given domain, but don't do it for intermediate graphs. We know that we would just stamp that out. So now I'm going to complete both of my last two in one go. I can interpret what a minus 60 on the inside means and what a minus 1 means on the end. So I'm going to shift my graph to the right 60 degrees and then down 1 unit. Okay. Easy thing, and where most people don't make a mistake, is with the shift right 60. So what I'm going to do is I'm going to transform our y-intercept just so we can see the common mistake. Is that we start to look at our graph and we think about counting squares. So if I'm going to shift to the right 60, then that's 2 squares. So I would take this and I would shift it to the right 60. Now I have to shift it down 1, and I go down 1, and there's my final location. I'm hoping that you can see my error. And that if we start to count squares, then we make the mistake on our shift down 1. Notice on my graph, I didn't shift down 1. I only shifted down a half, because the scale on my y-axis is a half. That for me to shift it down 1 unit, I'd actually have to shift it down 2 grid lines. So be very, very careful. That is easily your most common mistake as we go through to shift graphs. So I'm going to think instead of units. I need to shift that y to the right 60 degrees and then down 1 unit. And there's my finishing position. I'm going to now take all my key points and do the same thing. I'm going to shift to the right 1, 2 units, and down 1 unit. And I can continue on with that. This max gets shifted to the right 60, down 1. This 0 gets shifted to the right 60, down 1. And my minimum to the right 60, down 1. And if I've shifted my graph correctly, then I know my shape shouldn't change. And I'll get a little confirmation that my gold graph is the same shape as my blue one, so I did not change the shape. I should have done my sketch correctly. So what I see in gold then is my final graph. The problem is that I haven't graphed it for the given domain. I need to make sure that that graph fills up the entire space of 0 to 360. So what I'm going to do is I'm going to use that pattern to fill in the rest. I notice that to go from every max to a 0 to a min to a 0 to a max is going to take the same distance. So I'm going to repeat that. So if I kept moving forward, I noticed that if I go 1.5 grid lines, 45 degrees, and up 1, I get to my next middle. Then if I go 1.5 grid lines and up 1, I get to my next max, and so on and so on. I could complete that portion of my graph. I can then do the same thing going backwards at the beginning of my domain. 1.5 grid lines, up 1 unit, and I can connect. Now here's where I run into a little bit of an issue. I don't know where the rest of my graph should finish off or start. I have this little bit at the beginning of my domain that I need to fill in, and I have this little bit at the end. And I don't get to guess where that curve should go. So to be really clear with everybody, I don't get to go, oh, so let me just wrap that around. Or let me just, make it come up like this. Those are two estimates, and on a graph, I have to be as exact as I can be. So I'm going to get rid of those purple segments, and I'm going to make sure that I'm going to be as exact as I can be. So maybe what that means then is I need to do a little calculating. So maybe I want to take a look, and I want to find out what should my y value be at the very beginning of my graph when I have an x value of 0. And I'm going to make that substitution. And when I make the substitution of 0 in for x, I'm going to get that gold expression. I can now calculate that. And I can actually use my rotation angles to solve for that. I could now step out of that equation, rotate negative 120 degrees. That gives me a 60 degree related acute angle. Big angle, big opposite side. That means I've got -1 as an adjacent. And if I was to then calculate cos, my cos would be -1/2. So I can finish calculating that, and I'm going to get -1/2. I just came up with the exact value for what my y-intercept should be. So that tells me then that at 0, I should be exactly at negative 1/2. And now I can complete my graph correctly. Now, before we feel like we have to do the same thing at the end of our domain, we don't. Because I know that my normal period for my coast curve is 360 degrees. And if I do a horizontal stretch by a factor of 1/2, I know that my new period is going to be 180 degrees. Or I know that there needs to be 2 exact cycles that fit between 0 and 360. And so I'm not going to get a part of a cycle. I'm going to get 2 exact cycles. And so if my graph starts at negative 1/2, then it must end at negative 1/2 exactly. And what you'll see on your grid then is 2 exact cycles of our curve. There we go. The only thing we would ever need to see in your final graph, or is your final graph. So the only thing we would ever have to see is the gold. There we go. Hopefully not too painful. Let's make sure that we can go through as well and state out a couple key features. So as we take a look at question B, it asks us to state the amplitude, the period, and the phase shift. So I can do all of that directly from the equation. What is my amplitude? Well, my amplitude is my A value. My A value is negative 1. And so some of us may then feel like we should say the amplitude is negative 1. We have to stop ourselves. Remember what amplitude means. It means half the height. And you can't have a negative height. And so really when we talk about amplitude then, is we talk about, well, what is the number portion of the coefficient? So our amplitude would be 1. And you can get a little confirmation with that with your graph. Okay, what's our period? Well, we can get a little confirmation on our graph, but we also have our best friend, that we know it's 360 over k. What was our k value in this case? It was 2, and so we get 180 degrees. And we can confirm that with our picture. What was our phase shift? Well, phase shift is going to require 2 statements. Number 1, how much did it move? Our graph moved 60 degrees. The second part is in what direction? And we should be good that that was a shift right. So we should be good to be able to nail out all of those red properties from the equation and never need the graph. But once you have the graph, we should use it as confirmation. Okay, question C. State the coordinates of the maximum and minimum points. So given that domain, I'm going to have a series of maximum and minimum points. The first maximum point I see, I'm going to label in purple. I'm just going to put a little X through it so we can see that first max. So that maximum is going to exist at an angle value of 150 degrees and a y value, a function value of 0. I see that I have another max down here at the end. That would be at 330 degrees and a y value of 0. My minimums would then be the bottoms of my function. I see my first one almost at the beginning of the graph. That would be at 60 degrees and negative 2. And then I see my other one would be 180, 210, 240, and the same y value. What is the range of the function? Well, my range is going to talk about my y values. And so my y values begin at the very bottom at negative 2, and they go all the way up to 0 inclusive. Remember, we don't care how you express that, so please feel free to also express it in that form as well. And there we go. We went through a sketch process, and then we were also able to find some properties of the function. So let's try another one. And so what you see at the top of your screen now is another function. And this one I want to kind of do backwards. So let's find all of those properties listed in A, but let's do it directly from the equation. So let's pause the video if we're feeling confident and give it a shot. Okay, hopefully we're back. So we should see that we've got an amplitude of 2 because we can read that directly from the equation. We take a look at our period, and maybe we look at it and we say, I'm going to use my best friend, 360 divided by k. But I would hope that we would also look and say, there was no horizontal stretch. And so my period didn't change. So my period is still 360. What was my phase shift? I had a phase shift of 90 degrees, and I was going in the left direction. And what is the equation of the sinusoidal axis? That is what is the middle of my graph, and I know that that is y equals 2. It is my vertical shift. So we should be able to list all of those properties from seeing it up in our graph. We should now be good to go ahead and produce that graph. So I'm going to ask you to do 2 things again. This is never needed, but I'd like everybody to put a quick sketch down of what the graph of sine x looks like. Again, should take you 10 to 15 seconds. Go. Okay, we should be back. We know our sine curve starts in the middle, hits our max at 90, 0, 180, min 270, 0, 360. Connect it with a smooth curve. There is my base graph of sine x. Now, what I'd like to do is I'd like to go start to finish. And we're going to skip over all the intermediate graphs, and we're going to go directly to our final graph. This means I want us to show a little bit of patience as we transform each key value. So let's take a look at our y-intercept at the very beginning. In our y-intercept, what we need to do is we need to go through and do a vertical stretch by a factor of 2. That means it's not going to move. We then need to shift it to the left 90. Well, as soon as I go to shift that left 90, that key value is off the graph, which means I don't plot it. Now, it doesn't mean that I ignore it. I can use it as confirmation, but I am never going to graph that point. So I'm going to then omit that. Okay, I'm going to go to my next key value. That next key value is our maximum at 1. I need to stretch that vertically by a factor of 2. So it's going to get stretched up to 2. I then need to take that point and I need to shift it to the left 90 degrees, which would be 3 grid lines. And I then need to shift it up 2. And when I go to shift that up 2, I notice 1, 2. I'm off my grid again, which means I don't graph that one. However, in my mind, I know that I'm going to have that finishing point existing somewhere up here. I'm going to keep that in my mind as I go. So I'm going to get rid of all of that movement that we just did, but knowing that that key value is sitting up there somewhere. Okay, I progress my way through the rest of my points. So I'm going to take 180 and do a vertical stretch by a factor of 2. It is not going to move. I then shift it to the left 90, and I then shift it up 2 units. 1, 2. There would be my finishing position on my graph. So I'm going to get rid of all of that extra writing, and I know that that's finishing position is right there. Okay, I continue on with all my points. So I'm now going to take my minimum that exists at 270. So I vertically stretch it by a factor of 2, stretches it down to here. I then need to shift that to the left 90. I then need to shift up 2 units. 1, 2. And I'm going to finish on the x-axis. So I'm going to get rid of all of that writing again. There was my finishing position. Now I'm going to take my 360, do the same. Vertically stretch it by a factor of 2, no change. Shift it to the left 90. Shift it up 2 units. I now see my finishing position. Now, those are all the points, or the only points, that I'm able to transform and put on this grid from my base graph. And at the very least, I know this has to occur between those points. Now, it might seem that we don't have a whole lot in our graph that can help us, but we actually do. And so as you're kind of working your way through, I want us to notice that we have a couple things that we can use as confirmation. Notice that my zeros on my green graph, my original graph, are directly across from each other, so that's good. Also notice that my minimum is still my minimum. Okay, I'm going to put a couple key points down here so we can see some information. And then you can know how we can go through to transform and eventually graph. The first couple key things. Take a look at your movement between your key values. On my blue graph, I notice that from my minimum, I'm 1, 2, 3 units to the right, 1, 2, 3, 4 units up. Each part of my graph is symmetrical. So that means to get 1, 2, 3 to the left and 1, 2, 3, 4 up would also have to put me back at the middle of my graph. That then tells me that if I traveled 1, 2, 3 to the right and 1, 2, 3, 4 up, I would also get to my top. We get a little bit of confirmation as we move backwards. 1, 2, 3, 1, 2, 3, 4 gets me to the top. So I know that my graph would actually look like that. I just can't graph anything that's off the grid. So if I was to go through, I would then have to get rid of all of this stuff of which you would never put that on your graph in the first place. I'm going to be stuck with a little bit of the gold still on here. And I'm just going to clean up that blue that I erased a little of. What you would need to do is fill in your grid. Now, I want you to take a look and notice that my grid is still pretty symmetrical. Where you go in the future is you're going to be able to create a perfect graph from this because you'll be able to solve for what these exact points should be at the top. For us right now, that's the only part on your graph. And so if we were to ask you to graph that function, you would only show us, or only need to show us, the blue and nothing else. And so what I want you to take a look at now is our last problem for the day. And what I'd like us to do is to be able to go through and find key properties of our graph without ever having to produce the picture. The focus for today is being able to graph trig functions. However, being able to find those properties becomes useful, very useful. So what I would like everyone to do is pause the video now and work your way through finding the period, the amplitude, the equation of the axis, the domain, and the range for 2 complete cycles of that graph starting at x equals 0. Okay, pause the video now, give it a shot. Okay, we should be back. And so I'm just going to end up jotting down that we were looking for the period, we were looking for the amplitude, we were looking for the equation of the axis, and then we were looking for domain and range. So a couple quick things, and I would be a little concerned if we weren't able to go through and identify very quickly that your amplitude was 4. We can see the vertical stretch. We should have been okay to be able to deal with, since I shifted my graph up 6 units, then my equation of my axis should have been y equals 6. And then as we worked our way through, we should have been good to be able to say, well, I can see that I have a k value of 3. And so if I needed to calculate my period, well, my period is always 360 over k. So it would be 360 over 3, and that's going to give us 120 degrees. Again, you would never have to show any of that. We could just look at that as a horizontal stretch. And since I have a k value of 3, then I'm stretching my graph horizontally by a factor of 1/3. So what used to take 360 degrees now has to take a third of that. I arrive at my 120. Okay, the last part that I think that should have been pretty comfortable should have been your range. So to work through on the range, we should have been good with, well, my range is my y values. Since my graph had a vertical stretch by a factor of 4, then my old maximums that used to occur at 1 and -1 get stretched up to exist at 4 to -4. I don't even really care about the position of my graph. I know it's in here somewhere. And now I'm going to take that blue graph and I have to shift it all up 6 units. So this bottom that was at -4 is going to get shifted up 6 units to a bottom of 2. This top that existed at 4 is going to get shifted up 6 units to a top maximum of 10. And I would then have my graph, however it exists, lying in between. So we should be good to arrive that y must be greater than or equal to 2, less than or equal to 10, or we come in on the alternate notation. However, I'd like to address a different way to think about your range, and a way that may be easier. That rather than focusing on the vertical stretch and then the vertical shift, if we start to think of that graph instead as a graph that has a middle. By definition, the equation of your axis is the middle of your graph. And so I can tell directly from the equation that I have a middle that occurs at 6. Well, now if I go to use my amplitude, that is my vertical stretch, I know that my graph must exist 4 above from the middle and 4 down from the middle. And that's what can allow me to arrive at my maximum value of 10 and my minimum value of 2 fairly easily. So something to consider as you're trying to determine range. Okay, I want to jump into domain a little bit right now, because domain may have found to be a little tricky. And I would not have been shocked if I had a bunch of people that wrote down, well, I know that my domain for my coast graph is just x can be anything, so I wrote down x can be anything. Be very careful. And this is where we have to come up with that we're only including our domain for 2 full cycles. So the first thing that we need to then consider is I've been given a starting value. And we've been told in the function we start at x equals 0. So the nice easy thing then is I know that my x has to start at 0. But where does it end? Well, my 2 full cycles are going to depend on how long does it take to complete a cycle. And since it only takes 120 degrees to complete that cycle, then 2 full cycles is going to take 240 degrees to complete. So hopefully we can kind of see how we can build up some key properties of our graph without even really producing a graph. Okay, your job over the next couple days is to knock out as many graphs for trig functions as what you can get. Get very comfortable dealing with all your transformations. And my pressure to you on where you want to really get good with this is if you can avoid dealing with intermediate graphs and go straight to your final function. Okay, best of luck with your practice.